So, now see some applications of total internal reflections. First one is totally reflecting glass prisms. These are actually right angled isosceles glass prism, and for them critical angle is, so critical angle for glass air interface is 42 degree. So, because of that this glass prism gives a deviation of the 90 degree or 180 degree. Suppose you are taking one example like this. This is a isosceles right angled prism. This I have taken P, Q and R. This angle is of 90 degree, these two sides are equal. So, this is here the 45, this is here 45. Suppose you are taking any object over here, that is A and B, one incident ray is going like this and one incident ray is going like this. On face AB there is a normal incidence, so the angle of incidence is 0, and for this PR here angle of incidence is here 45 degree. Similarly, here is the 45 degree. We know critical angle for this is the 40 degree. So, angle of incidence on PR, that is more than the critical angle, and whenever the critical angle is more than the this one is critical angle of incidence, then the total internal reflection takes place. So, now the rays are going glass to air, but angle of incidence is greater than critical angle. So, these rays are reflected here and total internal reflection takes place. So, these rays comes over here. So, this is here the formation of the image A dash and B dash. So, by using here the right angled isosceles prism, we can get the image of object AB, and this is A dash B dash. There is no change in the size of the images, and also here the brightness of the image maintains here, that is we can get the proper brightness. So, this is the formation of image, and there is a deviation of 90 degree. Actual path of the ray of light was like this, and there is a deviation of 90 degree. Now, see another case where the deviation is of 180 degree. Suppose right angled prism is taken in this way, and here this angle is of 90 degree, and this we can take as here the P, Q and R. Suppose object is AB like this, we take two incident rays in this way here. This is here angle of 45, and this is also angle of 45, which is greater than the critical angle, because this angle and this angles are 45. Now, here it reflected from here and it comes here, again there is the same situation, angle of incidence 45. So, now the total internal reflection takes place here and here. So, image is obtained here. So, now B is coming here, A B dash and A dash, image is obtained here. So, now see in this case deviation is of 180 degree. So, now we have got the deviation of 90 degree and 180 degree by using the totally reflecting glass prism. Now, see here second application of the total internal reflection. See here the optical fibers. The working of the optical fibers based on the concept of the total internal reflections. See here what are the actually optical fibers. Optical fibers consist of several thousands of very long fine quality fibers of glass or quartz, and the diameter of the each wire is about 10 raised to power minus 4 centimeter. So, these very fine wires are used in the form of the bundles, and these optical fibers can be used for conveying or for the sending the telephonic signals from one place to another place. So, what happen in case of the telephonic signal? First, the sound signals are converted into the electrical signals, and then these electrical signals are converted into the light beam, and then this light beam is sent from one end to the another. And at the receiving end, again this light is converted into the light signals are converted into the electrical signals, and then in the sound signals. So, this optical fiber has got very important role in the communication system, and also these optical fibers, and this part is also used used for visualizing the internal part of the body like the endoscopy and other parts. because these are the very thin pipe that can be easily sent to inside the body, and the internal part easily can be seen by using the cameras. So, it has got the many importance these days. Now, see how does this optical fiber works. See here, as we have seen, optical fibers are made of the glass or quartz. So, this is the part of the optical fiber I have shown, and this the internal part which is by the dotted lines, that is actually the glass or quartz, and that is called the core of the fiber. Its refractive index is 1.5. And now, there is this the thicker line you are seeing here. These thicker lines are actually the coating here, that is called here the cladding. Cladding has got the material actually whose refractive index is around 1.48, which is less than the refractive index of the core of the optical fiber. Now, see, when light enters at a small angle inside the glass fiber here, first refraction takes place at this starting end, and then it strikes to the cladding. Since it is going from denser to rarer medium and angle of incidence is greater than critical angle, then this ray will be reflected from here, and this reflection is total internal reflection, and again the total internal reflection takes place here. So, after many times total internal reflections, ultimately this light comes out. When this light comes out, there is no loss of intensity at all. So, whatever the intensity was here, we can obtain the same intensity at the another end. So, there will be no loss of the strength of the signal at all, and easily we can use for transmitting these signals from one place to another place. And see here, this is a very efficient system of this one transmitting the signals, and these days it is utilized in many ways. Now, see here third application of the total internal reflection, that is about the brilliance of diamond. You might have seen this thing is here, diamond sparkles, they have got the great brilliance. So, this great brilliance is due to high refractive index of the diamond and its way of cutting, not just by its property or the property of the diamond. So, diamonds are cut in such a way, whenever the light enters from any face, or you can say when the light falls on any face of the diamond, and as it enters, there is a total internal reflection takes place. And diamonds are cut in such a way, there are the many times of the total internal reflection inside the diamond, as a result the diamond sparkles. So, the critical angle for the diamond and air interface is 24.4 degree, and its refractive index is the 2.42. So, the sparkling of the diamond is only due to total internal reflection.